Can you see that okay?
Yep.
Yeah.
And we are currently live streaming and recording.
Welcome everyone to the panel. Good afternoon, good evening, good morning, depending on where you are in the world. Welcome to this panel. For many of us, it is our afternoon. Many of us are in the West Coast part of the United States. I'm David Miner. I'm the moderator for this session. I'm a librarian at the library at UC San Diego, University of California at San Diego, excuse me. And I'm mostly going to be in the background for this session because it's a panel. I will note in a moment, I'm going to be putting into the chat links to our code of conduct, which especially in an online environment is very important. We do take that very seriously. Please use that link to report anything that we need to know about. I will also be putting in a link to a shared Google Doc for notes, which you should feel free to use, to add to read, to do what you need to do. And then lastly, I'll put persistent reminders to use the Q&A function in your Zoom client to ask questions. Our panelists will also be monitoring that and may have an opportunity to answer them real time. So don't wait till the end. Go ahead and ask them when you are ready to. So I think with that introduction, I'm going to hand it off to John Kunze from the California Digital Library, who will be the first speaker for this panel and be the first person to talk for it. So John, I'm going to stop sharing and hand it off to you.
Okay, thank you, David. I think my slides are centered. Okay, well, welcome to this panel, which is about broken links occurring exactly where they should not occur. And that is with the world's precious digital cultural heritage objects. A broken link is most apparent when you get a 404 not found page as a result of clicking on it. It's really surprising that persistent identifiers and permalinks have been around and available for 20 years, but few archiving and content management systems support them. The result is that long-term digital cultural heritage looks anything but long-term. Fortunately, others have led the way, and it's not rocket science to fix this with a few system design choices. Today's panel will consist of 5 presentations concerned with the need for persistent identifiers. Speakers will introduce themselves, starting with myself, John Kunze from the California Digital Library, and I'll use my time to try to set the stage for the speakers that follow. Why should we care about persistent links? Web links are the same thing as URLs, and the average lifetime of a URL is only about 100 days. At the end of its life, a URL link breaks, meaning it usually returns that dreaded 404 not found error that most of us have seen and lamented. So a persistent link is basically a URL that doesn't break. Some critics say, well, why store links at all? I just Google whenever I need my favorite cherry pie recipe. Unfortunately, that approach doesn't work because writers, scholars, and researchers spend months and years searching for and tracking down those hard to find links for the things they need to refer to. Also, large numbers of URLs get released into the wild, where many people and applications record and bookmark them. How do recipients know if they can trust those links to be persistent? Well, no one actually knows because no one knows the future, but we can sometimes make educated guesses. On balance, the vast majority of URLs were never meant to last, and persistent links are actually rare. So where can we go for persistent links? I know we can trust libraries, archives, and museums that safeguard cultural and scientific heritage because that's part of their mission, right? No. Shockingly, outside a few bespoke systems, most heritage organizations and their vendors do not have software solutions that support persistent links. How did things get so bad? Well, GLAM institutions, that stands for galleries, libraries, archives, and museums, they keep precious objects in DAMs, which stands for digital asset management systems. Like most object or content management systems these days, DAMs use database-generated object links, and these are exposed and used as URLs. These URLs change regularly, up to several times a year. That happens not because of unusual events, but because of ordinary maintenance and migration activities, such as when the database is reloaded, when the software is updated, or when the content migrates between different vendor systems. Changes can be widespread, breaking all system links at once. It's not a problem when viewing objects purely from inside the system because database magic ensures consistency. The problems comes from using those links from the outside and over time. When one of those change events happens, GLAM institutions have to scramble to repair the damage. It affects citations in articles, books, theses, blogs, dissertations, newspapers, and Wikipedia, as well as citations in Facebook, Instagram, and Twitter. It also affects URLs stored in linked open data records and library mark records, all of which feed search and discovery systems downstream. And it affects links harvested by aggregators such as the Digital Public Library of America. Seriously, if you cannot trust libraries, archives, and museums to do persistent links, who can you trust? 20 years of scrambling is enough. Fixing this should be a high priority. What's needed is some sort of permalink, which is a URL usually appearing on a formatted page next to an external label such as permalink or forever link or permanent link. Once published, a permalink in principle won't need to be changed. As the system changes, the permalink keeps working. An example is WordPress, which sits behind 40% of the world's most popular websites. Like GLAM systems, WordPress is database driven, but it still offers permalinks anyway. They work because when the database or software version changes, the software automatically keeps the permalink working. And if the domain changes, content managers can keep URLs working by maintaining something called redirects, which forward them. A persistent identifier, or PID as it's sometimes called, is a special kind of permalink that has an internal label to make it recognizable in the wild, where its original display context is missing. So PIDs with their internal label form a subset of permalinks. The internal label tells you what kind of PID it is, and there are several well-known kinds: ARC, DOI, Handle, Perl, and URN. Mostly, some kinds of PIDs charge fees. All of them make the institutions do the hard work of maintaining those redirects, and none of them prevent the major causes of broken links, which are human error, loss of funding, natural disaster, and social upheaval. As with all permalinks and life in general, PIDs come with no guarantees. But one important advantage of the PID is that internal label, which tells downstream recipients that the link's creator intended it to be persistent. This sets PIDs apart from the vast majority of URLs. Of course, a link that doesn't break is nice, even if you don't know it's not intended to break. So you don't need to know it's a permalink to enjoy it. Here are some PID examples with the internal labels highlighted. It happens that they all point to digital assets in well-funded organizations, which can afford to build bespoke digital asset management systems. For example, the Louvre Museum uses the ARC on the top line to identify the Mona Lisa. It is astonishing to me that PID and permalink options are not more mainstream for GLAM institutions, which are all about cultural heritage preservation. Instead, GLAMs have to build their own. As you'll hear in this panel, building their own takes real effort. With that, I'll turn it over to our next speaker, who is Deb Holmes Wong from the University of Southern California.
You're on mute, Deb.
Hi, I'm Deborah Holmes-Wong, Director of the USC Digital Library, and I'll be speaking with Zahid Rafiq, our MIS Director. We've been working together for almost 20 years now, and we're going to share our insights into DOIs and Content DM. USC is the University of Southern California is a large decentralized research university with many schools, departments, research centers, and libraries creating and or managing web-based content. The two largest providers on campus are the USC Libraries with its digital library and digital repository, and the Information Sciences Institute, who manage 4 national digital libraries. When ISI approached us about co-managing a data site implementation to get DOIs for USC content, we enthusiastically joined them. We knew we needed permanent URLs for our content. As I mentioned earlier, Zahid and I have been working together for quite some time, and the digital library has been around for even longer. It's migrated 3 times in 25 years, and each time we gave up any hope of maintaining the connection from our legacy URLs to the new system, leaving rotten links in our wake. It forced those who use OAI data to reharvest each time we migrated. When we were small, with a few 100,000 files, it was bad. But now we have 500,000 objects, 1.5 million files, almost 2 million unique users annually, and 1,000 licensing requests come in per year. In addition, the university is kind of encouraging scaler to with our digital library content, and having persistent URLs for use with these student and faculty projects is a must. So we are moving to a new system, and we knew we would be moving to a new system for quite some time, and we knew that we needed to do something so that we wouldn't be in quite the same place we were the last time we migrated. So basically, we have decided that we have to use DOIs to support our users and also to make it easier for those who harvest our content. But Content DM stood in our way. It has no support for persistent URLs, permanent links, PIDs, or whatever. And at the time that we were working on making DOIs available, Content DM basically packages its data so that you've got metadata with files. You can't individually expose files and provide a DOI for the file. What this means is that DM's internal logic makes it best if you're using DOIs for individual images or maps or monographs or ETDs, but it doesn't work if you're doing things at the EAD folder level, where you might have multiple objects with a common metadata record, or with a multi-part object like a thesis that has a CD that has other files attached to it, like videos and so forth. So one of the things that we found, it was very difficult to see the DOIs in DM. So basically we abandoned it. It's the way it's created for Content DM. It makes it very hard to do batch updates of anything. So we basically have only been able to provide DOIs through our OAI harvest. And Zahid is going to discuss our use of DataCite and workarounds with Content DM. Zahid.
Hello there. My name is Zahid Rafiq. As Deb mentioned, I have been working with her at USC Libraries for almost 18 or 19 years now. I'll start with an example of what a DOI looks like as far as our content is concerned, and then I'll move into a little bit of the implementation details as well. So we are using DataCite DOI service. And a typical DOI would basically look like a URL where you have a base URL, which basically is doi.org, then a data site assigned repository ID, which is unique for all the repositories. So at the moment, we have two unique repositories for USC, one for ISI and one for the USC libraries. And then the third part of the URL is the resource ID, which is assigned by the user. So we can come up with any valid characters that are valid URL characters to generate that. In our case, there is a certain meaning in this. I'm going to talk about that in a little bit as well. But that's pretty much it. And there you go. You have a DOI. Now, in order to get a DOI, there is a process of minting. So essentially, there is a service that is available from the data site, minting service, and you basically request, DOI with that specific resource ID, and if DOI is if that specific DOI is available, you will get it. And once you have it, you can essentially create the metadata for it in the data site Fabrica. So Fabrica is their backend where you can log in and you can manage manually, your metadata for your DOI. So the basic, information in the metadata, of course, is your resource URL, which is the URL in your system, and the title, description, and the other relevant information. The good thing is that DataSite supports DC metadata along with a few others as well. And that was good for us because our metadata in our system is already in DC. So it was relatively straightforward for us to do the mapping from our metadata to the Fabrica, metadata schema. Next slide, please. So the first system that I actually started working with was EMC Documentum. We started migrating into Documentum, I think around circa 2003. So prior to that, we were using an Xerces, digital system. I did not have any experience with that. But when we moved into Documentum, one thing that Documentum allowed us was to generate unique record IDs, essentially, based on our requirement. They had their own internal record ID as well that was unique. But on top of that, they allowed us to generate a record ID based on our requirement. So what we did at that time, that was like a conscious decision that we will have a collection abbreviation, and each of our collections, we have over 100 collections now, will have a unique abbreviation. So we will take that, we will put a hyphen and M for metadata, and then a unique number that is going to be generated automatically by Documentum system linearly, essentially, or sequentially. And we will use that as our unique ID for various records. And that kind of, helped us to sort of not rely on the internally generated IDs, which basically was just a string of digits or like sequence of digits, which had no meaning for us. We moved into Content DM, I would say like around circa 2011-12, and we chose the same approach in Content DM as well. Now, the thing with Content DM is that Content DM doesn't allow you to create a custom record ID. So what we did here was we essentially took the Content DM information, which is the collection ID and the record ID, and we concatenated that together, and we manually put that into our system. And we put all of this together with the data site repository ID, and we are good to go with the DOIs. Deb, next slide, please. So in order to implement this, there are 3 different APIs that we have to wrangle with. The DataSite REST API to mint the DOIs, DataSite Metadata Store or MDS API to create the metadata in Fabrica, OCLC Content DM API. So basically, this is what we use to pull our metadata out of Content DM. We do use a local MySQL instance just to create a processing queue to make it a little bit easier for us. It's not required. It can work without that, but it just makes life a little bit easier. And finally, there is a Java-based application which glues it all together, and it also updates the OAI records for our custom data provider. So we decided not to use the data provider offered in Content DM because it did not fit our needs. Next slide, please. So some of the challenges that we have to deal with is to essentially decide, are we going to create DOIs for record level or individual file level, essentially for each asset. And this becomes critical because we have multi-page assets as well. So at the moment, we have only created DOIs for record level. And we are in sort of pondering on what to do about the page level DOIs. So hopefully we'll have a resolution, and perhaps next time we present, we'll be able to present on that as well. Another issue is, during the migration to update the DOIs. So for example, we are moving from Content DM into a new system called Orange Logic Cortex. So, we have to update all the DOIs in Fabrica to point to the new URLs to the new in the new system. The third is the maintenance, in general. So people have started this service that we are using. So now we are getting requests by researchers and other professors to basically get DOIs for them as well. And of course, that's a more manual process than automated, because that's an individual request. And one of the issues at that point becomes who is going to be the maintainer of those records? Because if you are not going to maintain the DOI, it's going to be another broken URL. Thank you very much for listening to me, and I will hand it over to Alison and Megan. Thank you very much.
Hi, thank you there. Deborah, could we trade screen shares real quick? Thank you. All right, so I'm Megan Lonish. I'm the Digital Repository Manager of California Revealed, and we're undergoing the planning and preparatory stages of a migration from Islandora 7 to Archipelago. So first, a little bit about the California Revealed program. Our mission is to help California's cultural heritage organizations, public libraries, archives, museums, and historical societies to make the archival materials in their collections accessible for the long term to the public. We have 236 partners currently online, with about almost 100 more in our pipeline. So California Revealed as a program is about 10 years old, and this will be our second major migration. In 2010, we were founded as a California Audiovisual Preservation Program. We used Content DM as our original dam. We used the Internet Archive as our access layer, which we use it as a backup access layer at this point. We store all of our preservation master and access files for the long term on linear tape open storage cassettes. And between 2010 and 2015, we were actively harvested out of Content DM by the California Digital Library, Calisphere, the Digital Public Library of America, WorldCat, and we also were harvested by the Home Movie Registry. In 2015, we started our migration from Content DM to Islandora due to ongoing storage costs, but unfortunately, this massively disrupted our ability to have our records harvested. In 2017, the program transitioned into California Revealed, which expanded our scope from just audiovisual materials to include print-based materials as well as existing digital collections. In 2018, we launched our public-facing website as our primary access platform. Also in 2018, we restarted harvesting by our aggregators, during which we had a lot of growing pains. And last year, we started planning and preparing for our migration out of Islandora to Archipelago. So just to give a little bit of a highlights of what the identifiers we're using and the persistent URLs we currently house in our repository, to give Allison a little bit of context. Our object identifier is the primary identifier we use to talk about materials in our collection, or rather in our repository. It also serves as the basis for our file naming scheme and for the majority of our Internet Archive URLs. It is the major portion of the identifier portion of the Internet Archive URL. The only times in which we deviate from that pattern are when partners have already uploaded materials for digital collections, in which we just adopt that URL and move it forward rather than trying to duplicate content on the Internet Archive. We also have the ability to store ARC identifiers and use them as a reference point. And I'll talk a little bit more about that with Allison later. We are also, as part of our migration, planning on storing the PID for Islandora, or rather the node ID, to help with redirects or support other functionality as needed. So just in a very baseline way, why does California Revealed care about persistent identifiers and URLs? We need to ensure that we can manage our collection for the long term on our long-term storage solutions. We need to not trip up all of our aggregators again. 3 years is a long time to reestablish harvesting. And as John mentioned, we want to support educators and scholars rather than destroying their work of creating resource lists. And with that, I'll pass it to Allison to talk a little bit more about the technical details of Archipelago.
Thank you, Megan. Okay. Hi, everyone. I am Allison Lund, Digital Projects and Metadata Librarian for the Metropolitan New York Library Council. Today, I'm going to be talking to you about persistent URLs in Archipelago, an open source repository system being developed and supported at Metro. I won't cover everything on these next two slides in detail, but I do want to share just a little bit more information about Archipelago in case you're not familiar with the system. Archipelago is a slim, smart, open source repository software built on top of Drupal. Primary functionality is covered by a set of custom Drupal modules, the Strawberry Field modules, hence the Strawberry Doodles in this presentation. More information about the Strawberry Field modules and other components of Archipelago can be found in the various links throughout. Again, more links and information for further reading if you're interested. I'm now going to return to the technical strategy for persistent URL support in Archipelago. For standard out-of-the-box deployments, the persistent URL for every Archipelago digital object and or collection consists of your domain /do/UUID. This is whether your digital object or collection is ingested via a web form, remote API, drush, or batch import. Both California Revealed and Metro are in similar situations in terms of needing persistent URL support in Archipelago following migrations. Metro's development team, led by Archipelago's lead architect and Metro's Assistant Director for Digital Strategy, Diego Pina Navarro, has been consulting with the development team at Born Digital, the vendor who is handling the migration of California Revealed from Islandora 7 to Archipelago. Metro is also in the process of migrating our own shared repository, Digital Culture of Metropolitan New York, or DCMNY.org, from Islandora 7 to Archipelago. Most or almost all of the collections in DCMNY were harvested into DPLA in the mid-2010s timeframe through the now sunsetted Empire State Network DPLA Service Hub. That's unfortunately been closed since 2019. Any DPLA harvested or materials and collections will need to have redirect support once they are migrated. Also, some of our DCMNY partners use the current Islandora 7 URLs on their own websites. And as always, as others on this panel have said, we want to best support consistent and reliable access to our partners' trusted digital resources for educators, researchers, and users of all shapes and sizes. As with many systems, there are a few different options that could be taken for persistent URL redirection and support. Today, I'm only going to speak about the main option under consideration for California Revealed's particular situation. The current data structure in California Revealed includes the PID for their Islandora 7 environment, set up as the namespace :UUID and the metadata structure. Also includes ARC IDs that currently point to the Islandora 7 IDs. We'll get to the ARC IDs a little bit more later on, as Megan had mentioned, but for now, I just want to note that both of these two primary IDs, along with all of the other important IDs that Megan discussed earlier, will be part of the data structure post-migration. So, during the initial phase, the Archipelago multi-importer with the Islandora 7 Solar plugin will be configured to use the UUID from that PID for the Islandora 7 digital object for the new UUID for the Archipelago digital object. The next step in the process will involve using a specially configured internal resolver in Archipelago following the pattern established by a controller. This will take the PID and, if it is valid, redirect it permanently to the archipelago/do/UUID. The first implementation of this controller was tested on a small scale and all went very well. Returning to the ARC IDs in California Revealed, I'm going to turn back to Megan for just a little bit more context on that. So Megan, feel free to hop on.
Thanks, Allison. So the majority of the ARC identifiers represented in California Revealed's metadata actually come from the Internet Archive, with a very small handful actually being provided by our partner organizations. So essentially, when we publish records to the Internet Archive, they generate a ARC identifier as a part of their standard derivation process, and we are essentially just harvesting back that information from the Internet Archive to include it in our records.
Okay, thank you, Megan. Regarding those ARC IDs and redirect support, the development teams at Metro and Born Digital are currently exploring tapping into the ARC's API through the Internet Archive, in this case for California Revealed, to update the existing URLs to point to the archipelago/do/UUIDs. This could take place after or during the migration, and they are also exploring the possibility of generating new ARC IDs for future ingests if desired. And that wraps up our portion of the panel discussion. So with that, I am going to turn it over to Adrian. Thank you all.
So my name is Adrian Turner. I'm a senior product manager at the California Digital Library, and I'm going to keep this pretty short. I'm going to highlight the need for persistent URLs from the perspective of a regional aggregator, and going to end with some proposed recommendations for digital asset management system implementers, as well as developers and hosts and aggregators. Here at the CDL, we maintain a service called CalSphere, which brings together nearly 2 million digital primary source and cultural heritage materials from over 300 memory organizations in the state. And that includes also organizations such as California Revealed. And so CalSphere features digitized as well as born digital archival resources, photographs, ephemera, audiovisual materials, and so on. CalSphere is based on a harvesting model, and that's really predicated on content being hosted by a contributing institution in a DAMS, or a digital collection management system. And we harvest from a lot of different DAMs: Content DM, Past Perfect, Islandora, Preservica, Omeka, and on and on. So we take the metadata and thumbnails from those systems into CalSphere, which are sort of represented by this top arrow. And we support a lot of different protocols to programmatically pull in the content. OAI PMH is like the bread and butter protocol, but we also work with APIs and build custom fetcher and mapping code. So once the items are in CalSphere, they're indexed and searchable there. In order for a researcher to really interact with the resource, though, we point them back and link them back to the source harvested item. So they would, traverse back to the harvesting endpoint, and that's the sort of second arrow down there. Once the items are in CalSphere, we also create and assign a URL to them, and those CalSphere URLs are really based on the source item URL. So as long as that source item URL remains stable, the CalSphere URL remains stable as well. We also share content in CalSphere with DPLA through our role as a statewide service hub, and then DPLA, it works the same way as CalSphere. They harvest stuff from us. It's a harvesting model. Once the things are in DPLA, they direct users back to the source harvested item in order to fully interact with that resource. And then DPLA is in turn a conduit to other platforms and portals. So there's selected materials that they're sharing with Wikimedia Commons. There are also themed portals that are built on top of DPLA, such as the Black Women's Suffrage Digital Collection and Umbra Search. So we have all of these linkages back to in institutions dams that are represented by these dashed arrows, and that doesn't even factor in a myriad of other links that are out there in the wild along the lines of what John was referencing. So that are links that are citing or referring back to items in the dams or in these aggregations. So those are Wikipedia links, journal articles, finding aids, research guides, and on and on. So what happens if that source URL is not stable? And so what happens is 404 page not found madness, and the original URLs no longer work or resolve to anything. So here's just an example where there might just be say a simple domain name change or update to the URL scheme in the dams without any sort of redirect setups in place. And we've had this happen before. Another example, and you're hearing about these migration scenarios, is where content's migrated from one dams to another without factoring in redirection strategies or persistent URLs. So as a result, we do a real disservice to researchers that are relying on these stable links from those harvested endpoints. And it's hard to tell given the mysteries with how search engines like Google work. But broken links in 404 pages can't be good for search engine optimization. I mean, it can't be a healthy thing. Within the CalSphere context, we do have a mitigation strategy to somewhat alleviate things. So when these sort of URL changes happen, we can reharvest a collection to pick up the current form of the URL. That results in a new CalSphere URL. And what we can do is set up redirects from the old CalSphere URL to the new CalSphere URL. And that way, at least those old CalSphere URL links will continue to resolve to something. That said, any of those CalSphere records that are shared downstream with other aggregators like DPLA, they would need to be harvested by DPLA to pick up the current sort of URL to that source item. So it's not a perfect mitigation solution. And ultimately, our links, as well as all the other links that are out there, they're really only as good as the stability of that source endpoint. So what can we do as a community to try to safeguard against these things? And I'm just going to end with some recommendations or proposals here. So as a DAMS implementer, at minimum, consider redirect measures for any sort of slight URL domain changes when you're migrating content. Factor that into the strategy potentially. Ideally, implement a persistent URL format using a node PID scheme, and that's if your DAMS supports that. If it doesn't support that, please advocate for that functionality. And we know that there's really sort of relatively a small number of open source as well as licensed DAMs that readily support persistent URL schemes. Just as a data point, within the CalSphere context, there's only a handful of contributors that we work with that have persistent URL schemes running within their DAMs. So if you're shopping for a new DAMs, include persistent URL support in your requirements when evaluating and selecting a platform. And if your current DAMS doesn't support it, let your developer know through your feedback to their surveys and or in communicating wish list feature requests to them. As a DAMS developer or service provider, please explore options for readily supporting persistent URL formats within the system and as a core feature. And if you're working with an organization to migrate content from an existing platform to a DAMS that you're supporting or hosting, such as the case highlighted by Megan and Elson, please support strategies to redirect those older URLs. And last, aggregators have a role here. We can help. One way is to proactively identify broken links that are in our sites that we're managing, and when we find them, work with contributors to quickly resolve those links. And we can also promote awareness of the the need for persistent URLs and also advocate for them. If you have other suggestions for concrete, tangible steps we can collectively take to elevate digital cultural heritage resources to the level of things like scholarly publications, research data, which we commonly assign persistent URLs to, please weigh in through the chat, or would love to get your suggestions in the live notes document as well. So I'm going to end there, and I'm going to turn it over to my colleague Matthew McKinley at Omeka.
Thank you, Adrian. One second, let me share my screen here. All right. Hi, everyone. I'm Matthew McKinley with the California Digital Library. Formerly of the California Digital Library, now with the Omeka project. And I'm going to talk about integrating persistent identifiers into Omeka S. So the Omeka project provides several open source software platforms for publishing digital collections, with a particular focus on creating customizable and media-rich online exhibits. In addition to Omeka Classic and the newer Omeka S, we also offer Omeka.net, which is a fully hosted service implementation of Omeka Classic, as well as something called Omeka Everywhere, a suite of tools designed to integrate Omeka content with in-gallery multi-touch tables and mobile devices. A key difference between the two core platforms is that while Omeka Classic creates a single online site or exhibit, Omeka S creates a shareable resource pool that can then be published to multiple sites. Now, this has implications for integrating persistent identifiers, which I'll cover in a minute. So while the Omeka S core code is designed to be flexible and feature-rich on its own, a lot of the true customization power comes from installing and configuring optional modules. Just like Omeka, all modules are completely free and open source. They're developed and maintained by both the Omeka team as well as outside partners and contributors, and most are registered to a central list maintained by the Omeka project. Modules allow Omeka S users to build complex and feature-rich sites without overwhelming the novice user with options and settings. With that initial simplicity in mind, we decided it made the most sense to develop persistent identifier functionality as a separate module. So the requirements for a persistent identifier or PID module. Obviously, we want it to be able to create new IDs and assign them to both new and existing Omeka items by connecting to a PID services API. We also want it to be able to discover and assign PIDs that already exist within an item's metadata. The assigned PID should then resolve to a stable and user-friendly landing page for that item within the Omeka S instance. And finally, we wanted to design the module in a flexible way so that a user can swap out different PID services depending on their needs. Before going any further, I should note that an Omeka community member has already created a similar module for Omeka S for the purpose of minting and assigning ARC identifiers specifically using a PID creation utility called Noid. So why do we want to create another module? Well, firstly, as mentioned earlier, we want this new module to eventually work with a variety of PID services, not just ARCs. Second, the existing ARC module paints with a pretty broad brush. Once you enable it, a new ARC is minted and assigned to every Omeka item automatically after it is created or edited. We'd like more fine-grained control, such as the ability to assign PIDs only to a select group of items, or to locate and assign PIDs within existing metadata. Finally, this new module will be owned and maintained by the Omeka team, making updating, troubleshooting, and user interaction more straightforward. The main issue that came up when thinking about this module: what target page should we point to each Omeka item's PID toward? As I said before, Omeka S is designed to be a shareable resource pool that can be published to multiple sites. This means that the same item, when published to multiple sites, will have a different URL depending on the site it is published to. Omeka S does not set any restrictions on the number of sites an item can be published to, so you could potentially have the same item appearing on many sites in many different ways, and each with its own unique page URL. While discussing this issue with our team, we hit upon a few potential solutions. First, updating the PIDs for each site. This would involve a feature in the edit menu for each site that, when run, would update or create a new PID for each item. In this way, the administrator could update PID information when items are added or removed on a site. However, this introduces a lot of room for error, as the administrator would have to remember to continually run this process whenever items are changed. A second option would be assigning a new PID to an item per site. Unlike the first option, which involves changing the target URL of a PID for an item when it is published to a new site, this would create an entirely new and separate PID for the same item whenever and wherever it is published. This gets around the tricky manual process of option 1, but assigning multiple PIDs to a single intellectual object would not only get confusing, it kind of goes against the spirit of the whole persistent identifier concept. The final option will be to create a site-agnostic landing page. In other words, any item in Omeka S that is assigned a PID would at the same time have a simple public landing page created with the item's file and metadata, a page that is not tied to any specific site or item publishing status. This simplifies accessing an item via PID a great deal, with the caveat that you would lose any site-specific branding or functionality on that page. However, it would be easy enough to link from this simple central page to that item's specifically branded page on whichever site it is published, via a list pulled from Omeka's internal metadata. After considering these options and opening up the question to the larger Omeka S forum community, we decided it made the most sense to go with that third option. A key piece of this decision is that there already exists a stable, non-changing URL for each item in Omeka S accessible via the API. Now, this URL currently returns a JSON result containing the item's full metadata, which is informative, but not exactly user-friendly. So our plan is to make that API JSON result the initial target for each item's PID, then use content negotiation to immediately redirect the user to the more visually appealing site-agnostic item landing page. This should hopefully also future-proof the PID implementation, since we plan to keep that API URL for each item stable and unchanging going forward, even if we need to finesse the content negotiation bit for future versions. I've already mentioned all these planned features briefly, but I do want to reiterate that while we want to design the module in a way where you can plug in a variety of PID services, we'll need to pick a PID service to start with for the initial release, which we'll do in consultation with our forum community and internal team. And that's basically it. Thanks for listening. I'd love to hear any feedback you might have either in this panel, via email, or via our community forums in the link within the slide. And even if you have any opinions on sort of which PID service we should start with, those as well. So thanks again.
And thank you to all our panelists. I think that ends the formal presentations. We do have about 7 minutes or so for questions. And I will note to our panelists that a question just got posted into the Q&A box, so technically I'm supposed to read the questions. This one's a rather long one. I'm not sure. Are y'all able to actually see the question there? Maybe if you could just take a second and scan through it and take a shot at answering it.
I guess a clarifying question to the question. So the stipulation is that if you're migrating and you've managed to keep the persistent URL stable, there's still the possibility of having both versions of the content publicly available, as in say I have my Islandora 7 site up at the same time as Archipelago. Would that be a correct summary of that?
All right,
Um,
and let Diego's going to probably reply to that.
yeah.
But the way I read at
Mhm.
least one aspect of this question is that links can appear to be broken when they're pointed to content that's different but related. Maybe it's a different version, and something happened that you didn't expect, right? So that's another source of the broken link. It's not exactly what you thought it was. So unfortunately, nobody defines that in the persist. I mean, everyone has their own take on it. That can vary from institution to institution. So if that wasn't Diego's question, there's more I could say about that. There is some move to try to define different kinds of persistence. What do you mean by it? And that's possible to do with any of the PID schemes that I've seen. And you see examples of all of those cases.
Can I extend a little bit on this? So one of the discussions that we are having among ourselves about creating the DOIs for the asset themselves, this comes up in that as well. So when we are migrating, for example, all of our image collection, those assets, they are not changing. It's just the presentation of those assets is changing. So when we are creating our DOIs, at the moment, we are creating DOIs at the record level, which means it is a DOI for that presentation layer. But the discussion that we are having among ourselves is, does it make sense for us to create DOIs for each individual asset? And if we do that, that will never change. Even if we move from system to system, all those asset files, we make sure that their checksums are verified, and it's exactly the same file that we are moving from one system into another.
And I'll throw another wrench into it. Is it the copy that's publicly available that we're providing the DOI for, or do we also provide DOIs for the copy that we've got stored in a trusted preservation repository?
Yeah, I think it's an unfortunate fact of all human curated collections that curators tinker and they update and they improve, and that's part of their service. They don't really, they can't really be very precise about the policy, and some objects will not end up not changing and some will change substantially. And I don't know any scheme. There was a persistent identifier scheme that was actually computed from the digest. And that's gone out of favor, but it could, that's the kind of scheme where you will absolutely have a bit identical experience each time you go back to it. And that's the only one that I know, but it's not mainstream.
We have about 2 more minutes if there are any other questions. And Diego, if you're still with us, if your question was not answered or if you were getting to another point, oh, he just said, thanks, all your answers are correct. So everybody wins. That's great. So I guess last call for either any questions or if our panelists, if there's anything else that you wanted to say in closing. Otherwise, okay, yes, thank you again to all of our presenters in this panel. That's a very fascinating topic, and one that is, as John said, been around a long time and not quite yet solved. So fingers crossed that we can continue to move forward. Sarah, do I throw this back to you as host as we wind down this panel?
Yes, I am now going to go ahead. We'll now have about a 5-minute break before the next session, which is our the developers track session. So I'm going to now pause recording. I do want to remind folks, panelists that are here, we are still live streaming, so we're not pausing the live stream. So just be conscious of your conversation in the interim period. So.
Well, I want to thank you, everybody, to be on this panel with me. I really appreciate it. A lot of new things that I learned. So I'll see you around. Bye-bye.
Yeah.
Bye, everyone. Thank you. Thanks, Sarah, and thanks, David.
Thanks a
Yeah,
lot.
thank you.
Alrighty.
Good to see you. Thank you.
Bye.
Hi, Sarah.
Hi, how are you?
I'm well.
Good.
Hello, everyone else.
So I think we have, I'm looking at our, do we have everybody who is going to be presenting? I believe so. Here.
Yeah, I think the co-presenters with Lee may not be here yet. So
Okay,
I believe
great.
everyone on that paper was going to present.
Okay. And I think Terry and Lee are both, you're both playing recordings, is that right? So,
correct.
Okay. All right. And you're all set with that and you feel comfortable with that? Okay, cool. That's great.
So I assume we're going to break in between for questions after each of your presentations. Terrence, do you prefer Terry or Terrence?
I'm Terry.
Terry. Okay. Introduce yourself.
Although my full name pops up everywhere, like I see that
Yeah.
even in Slack here. And I've got two that'll go one after the other, so we can. I'm
Okay.
fine to do questions in between, or
It's up to you, whatever you think is easier. I guess see what comes in, maybe.
Yep. And then just I'll turn on the recording like right before. You'll want to just make sure we post up the just mention code of conduct before we start, all of that. So yeah.
Do you want me to just share my screen now for the welcome
That
slide?
Yeah, sure.
Present.
So I just got a notice that my internet connection is unstable.
Oh no.
Yeah, isn't it the best? I will see if I can move or address that in some way.
Okay.
So I guess as a lot of these are recorded, I won't need to give you a time warning, but I will let you know if we're running short around the questions and need to move on to the next presentation.
thanks.
Actually, my this is the best location in the house, so I'm gonna roll the dice.
Okay.
And I'll probably just leave the video off if that's all right.
Yeah, that's fine. That's sometimes has to happen that way. All right. Okay, I'm going to go ahead and resume recording. We are live streaming, so we should be on. So whenever you want to start. So we are recording now.
Thanks, Sarah. Well, as it is on the hour, I will start. So welcome everyone to the next session of Open Repositories 2021. This is Developer Track Session 2. I am Dimity Flanagan. I am at the University of Melbourne. Because I am in Australia, I would like to begin with an acknowledgement of country. So I would like to acknowledge the many unceded lands in which we are meeting on today. I myself am on the lands of the Wurundjeri people, and I would like to acknowledge and pay my respects to elders past, present, and emerging. So this is a 1-hour session. We have 4 great presentations lined up for you today. Now, a few housekeeping things to start off. There is an Open Repositories Code of Conduct. The link is on the screen there. We will put it in the chat. If you do come across any behavior that is concerning to you, you can look at that link and it will tell you how to report it. Other than that, we also have a shared document where notes of the session can be kept. Importantly, if any questions cannot be answered during this session, we will put the questions and answers into that note document so you can access it if you're watching this recording at a later date. So first up in our presentations is Terry Brady from the California Digital Library. So he has 2 presentations today, and the first one is called Developing a Serverless Application as a Docker Image. So I'm going to stop sharing and hand over to Terry.
Hello, I'm Terry Brady. I'm a software developer with the California Digital Library, and I'm going to talk about constructing a repository test strategy built on Docker. So the Merit Digital Preservation System houses digital content from the 10 University of California campuses. It's the backend repository for the Dryad data repository, and it houses the archives of 85 journals published by the California Digital Library. So before I joined the team in 2019, development environment for the system had been discontinued. It turned out it was challenging to keep a set of servers patched for a development environment and challenging to curate meaningful test data for this development environment. So when I joined the team, my first priority was to build a development environment so that I could safely modify code as a new person on the team. And Docker was my solution. So in order to explain what it was I built, I'm going to give a very quick and simplified tour of the Merit system. And this will likely be similar to many of the functions that your repositories perform. So at the heart of the Merit system, there's an inventory database that tracks metadata about objects in the system. Users can browse that repository through our user interface. From the user interface, it can initiate an ingest into the system. It uses Zookeeper as a queuing mechanism for ingest tasks. The ingest service sends new objects to our storage service, which selects a primary node of cloud storage in which to store the content. That could be Amazon, San Diego Supercomputer Center, or Wasabi. Once the primary copy has been saved, another task is added to Zookeeper. That is then picked up by our inventory service, which logs the location of the content in cloud storage into the inventory database. Now that we know the location of content in the inventory database, the user interface is able to browse the cloud storage and retrieve files directly from cloud storage. Additionally, there's a replication service that ensures that we have 3 copies of every object stored in 3 different cloud service providers. And our content is continually pulled by our audit microservice, which performs checksum calculations on the content in cloud storage and saves those results to the inventory database. So just to simplify our focus, I'm going to focus on really these core microservices shown here. So in order to construct a development environment for the Merit system, I started out by creating a Docker Compose file and built a Merit Docker network inside that Docker Compose file. Next, I took the MySQL database and rebuilt that using a MySQL 5.7 Docker image. For our user interface, I built that as a Docker image using a Ruby 2.6 Docker image, and I modified or overlaid some of the configuration files for the user interface in order to help the user interface find other components purely within the Docker network. Our ingest, storage, and inventory microservices are all each Java-based applications. Those were built from Tomcat 8 Docker images. And as I did with the user interface, each of the configuration files for these components was modified to help each component locate other components purely within the Docker network. For Zookeeper, built a replacement of that microservice using a Zookeeper 3 Docker image. And most excitingly to me, all of our cloud storage providers implement the S3 API, and there is a Docker container published by Minio that implements a Cloud 3 API as a Docker image emulating cloud storage. This allowed us to have a fully contained version of the Merit core microservices in which to test. Next decision we needed to make was to decide what content to persist from run to run when the stack of containers is stopped and restarted. For that, we determined we wanted to keep the content of the MySQL database and the content of the cloud storage service. And by preserving those two bits of content as Docker volumes, or persisting those as Docker volumes, we're able to stop and restart the container and hold on to content that was loaded in a previous test. So all of this got captured in one great big Docker Compose file, and I'll have the link to the GitHub repo for this at the end of the presentation if you're curious to take a look. So let me do a quick demo, and I'm going to use Visual Studio Code for my demonstration. I really like the remote editing capabilities and the Docker editing capabilities. I am going to indicate that I want to bring up a Docker stack, and I've predefined a little recipe of Docker Compose files called OR2021 demo. I'm going to start the stack of containers, and that's going to enable me to access this content. So the set of containers I described to you, you'll see they're starting up here in the Container tab. I'm going to navigate back to my browser, and I'm going to open up. The first page I'm going to open up is a helper page for testing my stack of containers. And what this page does is it gives me not only access to the Merit front-end service, but it gives me access to back-end ports for each of those containers that I'm running within the system. But for purposes of this demonstration, I'm just going to go to our user interface. And within this interface, I've essentially loaded basically an empty Merit repository. I'm going to go to a collection, and I'm going to add an object. And I've chosen as the object to add, I downloaded an image of the DSpace logo. So I'm going to add that into the repository. So I'm picking my DSpace logo. I'm going to provide some metadata to go along with this image. So I will call this OR2021. I'm going to indicate that I'm the creator of this object. I'm going to submit it. And as this is running, I want to go back to that page that gives me access to each of the individual containers. I've got some additional services that let me visualize the contents of my Zookeeper queue. So here I'm going to go browse my queue. And what we'll see is the ingest that we initiated of this OR2021 object with a logo. It has completed. So this has likely been fully saved to cloud storage. I'm going to return back to my collection in Merit. You'll see my object exists. It has a unique identifier. I'll click on that object. I will click on the image, and there you see the DSpace logo. The next thing I want to do is I'm just going to pop back into VS Code, and I'm going to stop the stack of containers that I started. So I've got a predefined little recipe here to bring down a stack of containers. I'm halting those, and one by one, each of my containers is being stopped. So we've got several benefits from creating this stack of containers. I created a development environment that allows me to test each and every microservice, able to actually remote debug every one of these microservices. It's a replicable environment, a disposable environment, fast to initialize, and it supports end-to-end testing. We've created some interesting variations of this stack that have been very helpful for testing. So in our core Docker Compose file, we've got the core microservices that I described to you. But additionally, we have a separate Docker Compose file that allows us to ignore the MySQL Docker container and instead use a clone of our production database. And we run this stack when we want to test the performance of SQL queries against millions and millions of records in the database. Additionally, we have a separate Docker Compose stack that allows us to test our audit and replication microservices. We have individual Docker Compose files that allow us to use VS Code's remote container debugging, and we're able to do remote debugging of individual microservices one at a time within VS Code. And similarly, because we do a lot of testing with the Dryad service, we have a separate stack that allows us to run a stack of Dryad containers along with the Merit Sword and OAI microservices, run that all together and perform integration testing. So as a new technical lead, building up this system in a Docker Compose file was an outstanding way to learn the new system, to become conversant in the components of the system, and really a great way just to have a common point of understanding of what the system does among the team. So I thank you, and there's the link to the repository containing all these Docker Compose files and my contact information. Thank you very much.
All right, so we can take some questions, and I'll prep the next presentation.
I'll throw in a quick question. So in terms of how long it took you to build all this, was that a massive time saver compared to other approaches? Like, what was that one of the key wins?
I would say so, particularly since I had no other development environment as an alternative. I would say within a matter of a few weeks, I had 2 or 3 components working together, which let me get started making some code changes. And then this has been kind of a work in progress, continually being refined. And then as other members of the team started using the stack, we've refined it further to, get to some of the edge cases that they've been trying to test.
Great. So we don't have any questions yet. So if you want to go on to the next presentation, everyone watching, feel free to just put in questions, whether it's from that presentation or the next one.
Sounds good.
Hello, I'm Terry Brady. I'm a software developer with the California Digital Library. I want to talk about deploying a serverless application to support your repository infrastructure. So the Merit Preservation Repository had a need to develop a reporting tool that would give internal staff transparency into system operations. And my wish in building this tool was I wanted to build something that we could modify quickly, just deploy code with fast turnaround, and for this application not to require any additional care and feeding of say a Rails or Django or Drupal framework. The Merit admin tool has a limited audience, just internal staff, infrequently used, and it's meant to be a read-only application, at least for now. And our goal with this was to replace dozens of one-off scripts and reports that we had. And so our solution was to learn about and develop this application as a serverless application. And in our context, that meant building an AWS Lambda. And I want to give you a very quick demonstration of the Merit Admin tool. I'm going to pop over to this application, and you'll see we have a number of predefined reports and queries that can be launched. And one of the most interesting queries is a query that we have just to categorize the contents of the Merit repository by MIME type. So this report is running. It's kind of aggregating quite a bit of information and then providing us with a summary and file and byte count per MIME type. And we have the ability to filter and toggle by high-level MIME groups or drill in and view details down at an individual MIME type level. So we have dozens of reports built into this application. And I want to tell you a little bit about how we learn to test and deploy this application. So if just to apply this to your context, places where you might find a serverless application to be useful would be replacement of cron jobs, reports, command line tasks, and any other infrequently accessed features of your repository. So I want to give you a super simplified view of a serverless application. At its heart, a serverless application has an entry point that is invoked as code. It takes JSON as input, and it returns JSON as output. That's the simplest view of a serverless application. Now, when you're running that in a web context, you may start with an HTTP request that you send to a load balancer. The load balancer itself formulates the JSON package that's sent to the application. And then the response is sent back to the load balancer, which converts that response into an HTTP response. So here's a view of a super simple Lambda. This is in the AWS Lambda editing screen. Here you'll see I've got an entry point called Lambda Handler, and it's essentially returning a message body that says hello open repositories. And if I test that code, you'll see I am returned a JSON object that says hello open repositories. So some challenges that we needed to solve in going with this framework for our application. First was how to package the code. If the code had been as simple as that example I showed you, all we would need to do is take our hello world Ruby file, zip it up, and deploy that zip file to AWS. In reality, most applications have software dependencies. In the case of Ruby, those are packaged as Ruby gems, and you use the bundle command to bundle up your gems into a vendor bundle folder. That that structure then gets added to the zip file and is deployed. Now, adding more complication, this was tricky as we were learning this process. If you have something like MySQL embedded in your application, you have binary dependencies that need to be built for the target environment of the Lambda operating system. So in this case, we've got some shared libraries that were built and compiled that need to go along with our gems in order to package. And all this was zipped up. So this was the traditional approach for deploying a Lambda. Fortunately, in December of 2020, AWS introduced a new feature to allow you to package code as a Docker image. And this was really attractive to our team. So what we did was we started out by packaging up sort of a common base image for all the Lambda applications we envisioned writing. So we're building this from a published Ruby Lambda base image that AWS has published. We're bundling in all of our core dependencies, and then we built and published to Docker Hub our own Docker image to use as a starting point. Next, in the case of our admin tool, we take that base image I described, we add our admin tool code into that Docker image, we bundle that up, and then we're able to push that newly created Docker image to Amazon's Elastic Container Registry, their Docker registry. And from that Docker registry, we can deploy the code to Lambda using a URI to the code in the Elastic Container Registry. Second challenge we ran into was how do we test our code before we deploy it to AWS? So you may remember in this diagram I was showing you that you need some sort of a load balance or some other application in a web context to package your payloads for your serverless application. And what we decided to do was mock the load balancer that AWS is running as a separate Docker container. So here we've got a Docker container we're calling our simulate load balancer. And with that, we were able to fully test our application. So to build this simulate ALB or load balancer application, we took a base Ruby image and we bundle in a little bit of Sinatra code in order to simulate the actions that are happening on AWS side within their load balancer. And from that, we published this simulate Lambda ALB application. So we're able then to combine our sample Lambda code with our ALB simulator, and together we can run and test our code in a browser using Docker Compose. Let me do a quick demonstration. So here I am going to run Docker Compose up, and I'm using VS Code, and VS Code will show you the Docker containers that are running. I'm going to go access those in a browser. And here you'll see I'm going to be taken to a web page with a very simple web client. If I click test lambda get, you'll see that hello open repositories text that I shared with you running within this Docker Compose stack. But now what I want to do is run my real application code. And I want to show you what that build looks like. So in the next instance, what I want to do is package up my admin tool code as the Lambda application that's going to be running inside of Docker Compose. And in order to do that, I'm going to run an alternative combination of Docker Compose files. In this case, I'm pulling in admin tool code as my running Lambda. It's restarted my, oh, that brought them down. Let me bring them up. I'm going to bring up my containers. You'll see they're starting. I'm going to pop back over to my browser. I'm going to reload the page. And now you'll see running within Docker Compose, I now have a running version of my admin tool. I can click on that same MIME groups query that we ran before, and this will run the application. What's really attractive to us about this is we already test for development purposes the Merit system using Docker Compose. So this allows us to test this admin tool code alongside the rest of our test containers. So what was really beneficial for us was the ability to build and deploy this code quickly. It's fast and it's easy. We can unit test our application before we commit to deploying to AWS, and we can perform integration testing with our other existing Docker containers. So if you're curious, I've got a link here to the code repository for the Merit admin tool, as well as our Docker Hub registry for our images that I referenced in this presentation. Hope you found this useful. Thank you.
All right, well, great. I can take any questions, and then afterwards I'll reshare those repository links in the chat.
I don't believe I've had any come into the Q&A.
All right, well, I'll post those links.
Great. And those recordings are already up on Zenodo. We can put those links into the chat as well if you want to rewatch the demonstration, and also the contact details for Terry if you have questions after looking at it in more detail. Okay, great. So next up, we have Hardy Pottinger again from the California Digital Library. And I believe we have a live demo to create a developer workspace challenge. And I believe Hardy has been polling the attendees to see what the live demo will be about. So I'll pass over to you, Hardy.
Okay, thanks. Let's see if I can share my screen here. There we go. Can you see my developer environment? Screen,
Yes.
my ID, great, awesome. Let's see, my name is Hardy Pottinger. I'm a publishing systems developer at CDL. And I'll mention up front, we're hiring a senior developer position. If you're interested, catch me later and I'll get you the description. I'm here to show you how to make a dev environment using Lando. Lando is a single config file, containerized everything, local dev tool. It's built on Docker Compose, like what Terry just demonstrated, and it's similar, but it smooths out some of the rough edges of Compose, and it's fun. I had big plans for this talk, but plans changed. I emailed everyone to ask who told Sked what they were interested in a session, and I gave you a link to a page where you suggest and vote on a project. The winner of that process was Omeka S. So let's go to that GitHub page, and we're going to need this README. So I'll leave this up. I've already cloned Omeka locally. So Lando has an init script, so I'll run that now. Lando init dash full. And it's going to ask some questions. We're already in our working directory, so we'll use that. What recipe do you want to use? Recipes bundle a bunch of common configuration for certain types of environments. They're not required, but I always pick the LAMP recipe to start out with and then delete what I don't need. In this case, Omeka is a LAMP app, so we'll go ahead and keep it. And we're already in our project root, so dot is a fine selection for web root. And what do you want to call this app? I will call it Omeka. And let's see what we've got here. We just got a new Lando config file. I will drag this down slightly. Oop. Hello. All right, we will live with that there. So we've got a app server and the services that are configured are an app server and a database. Services represent different Docker containers, and they provide the stuff that your project needs to run. The init gave us an app server and a database, and there are a lot more options for different containers. You can have a Solar instance or Elasticsearch, Tomcat. Any Docker image can be used as a service. And then it also created some tooling. Tooling is a way to interact with the services that are in their containers. Reminds me, let's look at Omeka S. Right, so we're gonna need something beside PHP. We're gonna need Node.js. And I happen to have a configuration for that I already wrote for OJS, which is another PHP stack. So I'm gonna copy all this config from an example that I have, and we will drop that in here underneath our web root. And what that did is it runs a bunch of different build steps to pull in extra stuff that you might need. In this case, we're pulling in all of Node. And then this I borrowed from a image that I built for OJS, but we don't need any of this PKP stuff, so I will delete that. And we've got this npm run build, which is different than what Omeka said we needed to do. Let's go look and see. we need npx gulp init. So I'll copy that and we'll put that here. All right, great. And we will save that file. Now, after we've copied that, and it's time to launch our airplane here. Lando rebuild. And I'm going to go ahead and pass it the Y command, her Y flag, which means just answer yes to any questions. Oh, and I made a typo there. Lando rebuild -Y. So we've launched the plane, and now let's finish building it while we're flying it. So let's add some tooling. There's some various commands that are run here on the app server. So I'll just add a couple more. This is not something you normally do, but it's perfectly fine for this demo because tooling does not require recompile. So we're going to run npm on the app server, and we're going to run the command npm. And we will do also npx service app server command npx. So those commands are ready. And we also need to configure the database. Omeka provides a template to use, and I took the liberty of already copying it over in here. The configs for the default config for Orlando is create a user for MySQL called LAMP, password LAMP, database name LAMP, and the database host name is database. And I went ahead and added the port, the 3306. That shouldn't be required, but I have trust issues, so I went ahead and added the port number there. And the build is still running here, so I'll mention this sticky over here. I've got links to the Lando docs site, and also this Git.io link is to a cheat sheet that I wrote for a workshop that I did at Code for Lib earlier this year. And that gives a nice overview of how things are working. And I recommend going ahead and getting that. And then if you want to do a more in-depth dive on Lando, then you can navigate from that cheat sheet to the rest of the workshop files. And we are good. It is running. So now we can kick off the Omeka installation process, which is here. I'm going to, Lando creates, it has its own SSL certificates built in. So if you want to test SSL stuff, you can, but I'm not going to tempt the spirits, and I'll just do it normal HTTPS. And there's the Omeka S install process. So this is running on my container. The app server is running, and I can create a user in here and continue on with my Omeka S installation and play around with Omeka S. This is a working dev environment, and you can make any changes to this code over here, and it'll be instantly reflected on the other side. So if you wanted to follow along with that, then you'd be able to check out Omeka S, and it's a really fun system. I do recommend playing around with it if you get a chance. To wrap up, I want to be sure you know that Lando has a lot of flexibility and many more options than just PHP in a database. You can use Lando to build a dev environment for pretty much any software. I did a workshop at Code for Lib, and the repository for that contains a lot of working examples for different projects, including Sambera, DSpace, and OJS. I have one for ePrints that I'll be loading up soon, and the DSpace one could be adapted to Fedora pretty easily, so I'll put that up later in the week. How am we doing for time?
Yep, we're fine. We've got a couple of minutes before we hit 10, or
Cool.
1 minute now.
I'm pretty much done with the demo, so if anyone has
Great.
questions, let me know.
So you said you could pretty much use it for any of the different applications or systems. Are there degrees of difficulty for setting up the different systems, or like OGS versus ePrints versus a maker, or?
Well, OJS is pretty much the same process as this. It's a lamp stack application, although the details are a little bit funny. So that there's a README associated with that example, that repository that I have up in my workshop repository. The one for OJS has a description of the bits that you need to do to get things working, but it's not that difficult. No, most of this stuff works pretty much out of the box. There's a little bit of funkiness with solar, solar being solar, but no, the workflow is basically just do the PHP lamp stack and then delete all the PHP stuff out of it and add the services that you want. So make a list, and that you can follow that cheat sheet that I have, or you can go with the example. And they're actually this Lando file is very similar to a Docker Compose file. So any existing Docker Compose stuff that you find online, you could easily convert to Lando. So there's a site called Awesome Compose, or Awesome Docker Compose. There's examples in there for all kinds of different web projects. I have an aspiration to do that for all the different repositories, and I'm working towards that with the example folder for that workshop. I haven't gotten them all done yet, but I'll get there someday.
That's great. It'd be wonderful if you could put the link into the chat. I'll copy it over to the shared Google Doc, because I know that this is a tricky time for a lot of for a few time zones out there. I know it's very late at night for some people, so they may not have been able to make this session, and we'll be watching it later on record. So just so you know, we will put the links in that shared Google Doc. So thank you, Hardy. That was really interesting, and I just can't believe, like, you make it look very easy. As someone who is not a developer, I was like, well, that was very quick. So our next presentation and our final presentation for this session, we have presenters Yinlin Chen, Tingting Jiang, and Lee Hunter from Virginia Tech, and they will be presenting building scalable serverless digital repositories using Amplify open source framework. I believe they will be playing a recording, so Hardy, if you could stop sharing your screen, and I believe we're passing it over to Yinlin to share their recording.
Hi, my name is Lee Hunter, and I'm a developer on the team at the University Libraries at Virginia Tech. Today, I'll also be joined by two of my teammates, Tingting Zhang and Yinlin Chen, and we're here to talk about our experiences with building serverless online repositories using Amplify from AWS. So I'll just be giving you a quick general overview of our software stack, and then Tingting will talk more in depth about AppSync and GraphQL. And finally, Yinlin will discuss our application's performance and then summarize things and give some notes on our plans for the future. Some of the reasons that we chose Amplify. Amplify allows us to develop locally, but then our entire stack is deployed into the cloud. And the stack is built on a collection of microservices, meaning that there are no actual physical servers that we have to maintain.
And this was attractive to us because we're a pretty small team, and this allows us to focus more on the business logic of the application. It also allows us to get insight into the state of our platform through AWS's monitoring and logging services, and we can leverage the auto-scaling features of AWS to provide pretty exceptional performance while also minimizing our costs. Our platform is a multi-tenant platform that's responsible for powering several different repositories, all from the same code base. And there are two main functions of the platform: providing online access to materials and also providing secure and consistent preservation of those materials. This is accomplished through a suite of microservices that do jobs such as bulk ingestion from local storage, minting unique IDs, derivative generation, and fixity checks to ensure the integrity of deposited materials. Here's an example of a few of the pages from one of our repositories. Materials in our repositories can be grouped into collections, which can contain any number of individual items or any number of sub-collections. Our front end is built with React, and we use Mirador to provide a good user experience for viewing static image materials. Here's a breakdown of some of the services that we use to power our platform. We use GitHub to manage our application code, S3 for document storage, React for our front-end code, and Amazon Cognito for identity and credential management. Our backend runs on a NoSQL database, DynamoDB, and search and indexing is provided by Elasticsearch. Another feature that's great about Amplify is how easy it makes deployments. Every time we submit a pull request through GitHub, Amplify automatically provisions a preview server and runs our code's test suite. If the tests pass, then the application is deployed, where the changes can be reviewed before they're merged into our main branch. So now I'll hand it over to Ting Ting, who's going to talk about AppSync and GraphQL.
We missing some audio.
Okay, give me a sec. Sorry.
It's okay. You might just have to talk over the video.
Thank you, Lee. With the React framework in the front end, our platform uses AWS Amplify's GraphQL transform to automatically create the backend API. During the process, we utilize AWS managed service AppSync to facilitate the development of GraphQL APIs, handling the connections between GraphQL data models with data sources managed by Amazon serverless services, including DynamoDB database, Elasticsearch engine, and the CloudWatch monitoring service. To make all these connections and API establishment, we need to perform the following key steps. First, design and define your GraphQL schema, then connecting the data operations such as queries and mutations with the corresponding request-response resolver templates, as well as selecting the appropriate data sources for the resolvers. To start the process, first define your data model, which is the schema GraphQL file in your Amplify backend API folder. By running Amplify push, a full cloud formation template will be set up for you with your new API. Here in the AppSync AWS console, you can find the GraphQL schema you previously defined here. On the right panel, you can find all the queries and corresponding resolvers. For example, to get a particular collection, the resolver will connect to DynamoDB collection table. Or if you would like to search objects with specific query parameters, the search resolvers will connect to Elasticsearch domain with the default request response resolvers pre-generated for you. Then you can execute your search query and get the desired search results. While this is very neat, oftentimes these data models and default search behaviors are not enough to meet our specific application requirements. For example, in most cases, user will prefer to perform a fuzzy search instead of an exact match. Or one of our applications requires to search for some combined types with sorting capability by some common field. Then this can be achieved by using GraphQL's interface or union type, as it represents the generalization of multiple types. Other scenarios include search with complex and/or operations, multi-field or full text searches, and being able to provide custom searchable input beyond filter and sort. Here, we purposely build this GitHub repository with a suite of AppSync GraphQL custom resolvers, as well as a step-by-step guide on how to define customized schema and attach these custom resolvers to deal with the real-life search requirements. These kind of searches are used intensively by applications built on top of our digital library platform. We hope by contributing this repository to the community, it will be helpful to anyone with a need to fulfill your own GraphQL data fetch requirements. Okay, with a brief description of our backend using AppSync GraphQL, I'll hand it over to Yingling on the performance of our digital platform.
Thanks, Tintin. About the performance, in the past, our web application is deployed in a server in our local environment. A user usually takes 1 second to browse an image from our site. After we move our entire software stack into the AWS, our performance increased. So now a user only needs to take 100 milliseconds to browse an image. So we got more than 10 times faster than before. We also use a testing tool to test our website's performance. So you can see here we start from 100 users rendering access our site to browse different kind of image creations in our site. From 100 increase to 500 users. And you can see in here, the response time is almost remain the same, no matter how many users in here. Because we utilize the edge computing and the cache provided by the AWS. So no matter how many users in here browse converting access our site, our performance is still fast and stable. So in the past, we deploy our website in the server we purchased. So our performance is limited by the computer resource we have. Sometimes we're afraid our website become too popular, then our server cannot handle this. But now, that's not our concern anymore. As our website keep growing, we are confident that our website can support that and still provide fast and stable performance to the users. And also, there are a lot of things we need to maintain in the past, but we don't need to maintain now. So our future works. So we continue to improve our website, data functions, microservice, and also we control our cost to assign the CPU and the memory usage because we want to like pay less, because when we use well, we pay less. And also continue move our old website into our new digital library platforms. And also we continue to increase our functionalities. Like we can start using the AI and the machine learning to do image process and the natural language processing. So our website and our source code is open to public. You can see here. So you can see this is about our projects, and we open source our code. You are feel free to see and check this. Thank you.
Thank you, everyone. That was a really impressive result. 10 times faster performance and cost savings as well. Very, very, very good success story there. So again, I don't think we have any questions. I think maybe the late time for some people is meaning they're ready to go to bed. But again, if you do want to put any further links into the Google Doc, that will be helpful for people watching at a later time. We have a couple of minutes of the session before we wrap up. If anyone wanted to add anything, if you had any questions for other presenters, feel free to jump in. Otherwise, I will just put the next session up on the screen.
I think this is the last session.
Yes.
Yes.
Next session in 7 hours.
Yes.
So
for some of us, the next day. For some of us, the same day. So
some of us after a long day at work. So I want to thank all our presenters today. It was 4 really interesting demonstrations. And we will make everything available, recordings at a later date when they become available. So yes, our next session is in 7 hours. There are 2 presentation sessions up for you to choose from. I will be moderating session 9. So if you're there, I will see you again in 7 hours. But also a shout out, because we are very grateful to our sponsors for their contributions to open repositories. We would not be able to run it without them. It is a very big global conference. So thank you. So a final thanks to our, and someone just wants the link to the Google Doc. I will put that in there. So a final thanks. We'll pause the recording now, and I hope everyone has a good day or a good sleep. Thank you.
Thank you all.
Thank you.
Sorry, I'll get the link up once I stop sharing. There we go. There you go. Well, thank you. I'm not sure what time it is in your American time zones, but it's probably late. I don't know if you need to go have